as I said, a topic for another day and a far more technical audience, probably. But, I think that it's important to keep in mind that these other third-party programs are sometimes themselves interpreted as well. Java, Python, C#, and things like that. Further development, then, would be to calibrate and validate this. Somebody can go and calibrate and validate this on region-specific data or, adapt this. Obviously, it's based upon Portland, and, the framework has since then been specialized using other third-party programming to other areas. And certainly, we could take this model, transfer it to other regions. The structure and many parameters should be transferable. As I mentioned, we will continue to improve the runtime performance and explore all the different scripting innovations that we can take advantage of to do that. I think that the neat thing about having this in Voyager is it doesn't require a lot of third-party libraries or a lot of research into distributed processing code to do that. I mean, we can cluster this very easily, as we've demonstrated, and we can also take advantage of multi-dimensional arrays and things like that to continue to improve the runtime performance and continue to improve DBI, etc. And with that, I'll open it up to questions. I guess nobody typed in any questions, which either means that they're asleep or that it's just above their head, or they're interested and they're just waiting to type in questions. Mark is on the line, and oh wait, there are some questions now. Okay, so Chief Heng asks, how do you calibrate and validate this sort of activity-based model? Only to certain time or each time interval of the day? So that's definitely a question from Mark. Do you want to take a stab at that?
Pretty much the same way you would calibrate a four-step model. You have hopefully some survey data. Assuming you're not going to estimate your own models completely from scratch, if you're just taking parameters from an existing model, you still want some data on observed behavior, plus you have census data or some kind of, in the U.S. we have CTPP data, which is a little bit out of date now, but should be better again in 2 years. You have, for validation, of course, traffic flows, and, onboard counts, things like that. But so you have, it's more or less the same process as validating or calibrating a four-step model. I would say that just validating your base year doesn't, often that's taken as the sort of the proof of whether you have a good model or not. And I would say that people tend to fool themselves a lot of times that way, because you can calibrate and validate any model to the base year, even if the model only has just constants and isn't sensitive to any policies. The nice thing about activity-based models is that they tend to have good sensitivity to a lot of different types of policies, and all the way from trip generation and auto ownership down to load choice, and and tend to. So I think, especially for things like time of day and peak spreading, they can have more realistic effects. Whereas in a lot of four-step models, you don't really see any peak spreading effects when you simulate policies, even though your base year validation might look good.
Okay, and certainly if you wanted to estimate this from scratch, it's sort of a straightforward, maximum likelihood estimation of multinomial logit using the household travel survey, basically, right?
Yeah, and there's plenty of detailed reports around on model estimation for these types of models that you can get from the MPOs who've done it, like Atlanta, Sacramento, Portland, Seattle, different regions.
Okay. All right.
Different examples.
We have another question here from Chifeng about pricing of one license cluster, one 8-core machine versus one cluster license plus one node license plus two quadro cores machine. I mean, I can't get into the complete details right now of our pricing structure, but if anybody's interested and has a particular specific situation, I think it depends a lot on what your specific situation today is. So certainly you can contact your sales representative to find out more about pricing. We're not going to discuss the actual prices today. Another person asks,
I noticed I didn't really answer the first question about the specific question about whether you validated each time of day. And yes, we do. Because these models tend to have time of day models and travel scheduling models, you definitely want to calibrate your time of day distribution to observe behavior.
So you do need data with fine temporal detail then, in order to calibrate the model. You have to calibrate by time of day.
Yeah,
but I guess it's not separate
preferably
models.
From a survey, but at least traffic counts for different times of day. Yeah.
Right. And it's certainly not going to be, it wouldn't be the case that you would calibrate several different models for each time of day. The idea is that the model produces activity day patterns for the entire day, correct?
Right, the model's time of day is a component, is a choice up to the model, so it's one thing that you calibrate. You calibrate your mode shares, your time of day distributions, your trip length distributions, your number of trips generated by household, things like that. So it's just another, okay.
Another question, how do you predict future demand by using activity-based data?
I'll let you go back to your previous question.
Oh, sorry. I was having some audio problems there. I couldn't hear if you were speaking.
Okay.
So how do we predict future demand by using activity-based data? I think, we've addressed the development of this thing, but I think a lot of people have questions about how this is used for forecasting. So do you have any comments on that, Mark?
Again, it's the same general process you'd use with a 4-step model. You have your future year networks. You have your future year land use as inputs to the models. There's one extra step in that you have to create a future year population with your population synthesizer, which means you need to forecast the attributes of the population that you're controlling to when you create your synthetic population. So in your example, you would need by zone future year forecasts of income distribution and household size distribution. Some MPOs from their land use model produce those kinds of things already. Some of them only produce things like income distribution at the regional level, regional forecasts, and then you have to make some assumptions about how those translate down to a more fine level, whether every zone has the same change in income distribution or whether some zones will be different than others. So those questions just depend on how you do your land use, future year land use forecasts and population forecasts. But in general, other than that one step of creating a future year population, synthetic population, it's basically the same as now. You take your future year networks, your future year land use, like employment and population by zone, and just run the models.
So I have a follow-up question on that, Mark, for you, which is sort of maybe underlying here. The model itself is a simulation-based model of travel behavior, which means it's stochastic and has some underlying randomness in the outputs because it uses Monte Carlo simulation of choice probabilities. So are there any considerations that we have to take into account in interpreting the model outputs as a result of being a simulation-based output rather than a sort of equilibrium aggregate model of mode shares and things like that? How do we encourage the model to attain some kind of equilibrium? How do we mention equilibrium? How do we stabilize the model? And, how many times do we need to run it to average together results to make sure that they're equilibrated, things like that. Would you recommend method of successive averages with the feedback loop? Any other insights on that?
I don't think that it affects the global equilibration very much. What it does do is it means that the further you break down your forecast results, the more susceptible they'll be to what we call stochastic simulation or random simulation errors. That way, for each time we pick a choice for a specific household, we take the probabilities and pick one discrete choice. So, we might say that a given person for a given trip has a 75% chance of driving alone, a 15% chance of driving carpooling, and a 10% chance of using transit. And we pick a random number from 0 to 1, and based on what that comes up with, if it's 0 to 0.75, we put them as a drive alone trip. If it's 0.75 to 0.9, we put them as a carpool trip, and so on. So, the law of large numbers says that if you have a huge population and you do that, regionally, your results are going to be pretty stable. But the more and more you break that down, like if you want to look at mode splits for all the trips going from zone 1 to zone 50, you might not have enough of those to make that one thing very stable. So what you can do there, if that's really important, you can do multiple runs of the whole system and average them. One thing we've done is to try to synchronize the random, because really, usually in most forecasts, what you're interested in is the difference between your base scenario and your policy scenario. So if you can synchronize the random choices between those two scenarios, you can sort of cancel out some of that random error and really focus in on the differences between the two forecasts. Sometime we can take a look and see whether it would be, how we could implement some of that kind of synchronization within the cube scripts.
Yeah, that's interesting. We might be able to, using the RAND seed function, actually. If we seeded the random number generator using household-specific ID numbers or something like that, it should be possible.
Yeah, that's pretty much how we do it. You give each household a separate seed, and maybe each person, and store it as a data item, so that even if the random numbers sort of get out of sequence for one person's forecast, they're sort of back in sequence for the next one.
Right.
Or back in synchronization. But that's it.